Due to California's climate pattern, late summer is when temperatures in coastal areas tend to be at their warmest, humidity levels at their lowest, and vegetation at its driest level. This is also the time of year when strong winds, known as the Santa Ana winds, develop. Because these winds often occur before the first significant rainfall of the season, some of the most hazardous wildfires seen anywhere in the world occur in California. In addition to the lack of rainfall making vegetation extremely dry, and the decades of fire suppression in California, generating over accumulations of wood fuel in forests and woodlands, the Santa Ana winds play a critical role in the development of very large and dangerous fires. The occurrence of Santa Ana winds make it very difficult for firefighters to control wildfires before tens of thousands of acres and hundreds of homes have been burned. In this podcast, we will investigate the atmospheric and topographic conditions that lead to the development of Santa Ana winds. So what are the Santa Ana winds and what causes them? The Santa Ana winds are intense easterly winds, meaning they come from the east and flow west, sweeping across Southern California and northern Baja, Mexico, and are most conspicuous in September through November. These white arrows depict the flow of wind, moving from east to the west. During late summer and into late fall, the Great Basin tends to be cooler than the LA Basin. This causes high pressure to build periodically over the Great Basin, as depicted by this high pressure center here. Remember that in the northern hemisphere, air flows clockwise around high pressure systems. For highs located in the Great Basin, that clockwise flow pushes air into the LA Basin from the northeast and the east. So the Santa Ana winds actually start in the Great Basin as cool or even cold wind. But as they drive those air masses westward towards the Pacific coast, the air heats up, dries out, and the winds strengthen. Why are the Santa Ana winds so intense? Topography plays a big role in the formation of the Santa Ana winds. Named for the Santa Ana Mountains and the Santa Ana Canyon, these winds are intensified by the mountainous topography of Southern California. As winds flow from east to west and encounter these mountains, the passes and canyons act like wind tunnels, forcing the air into narrow gaps. Under these conditions, wind speeds increase, sometimes gusting to hurricane force speeds of 40 to even 100 miles per hour. Wind actually accelerates as it moves through narrow mountain passes and canyons to the north and east of Los Angeles. The winds accelerate further as the air masses drop down into the lower elevations of the LA Basin. So why are the Santa Ana winds so hot? The atmospheric phenomenon responsible for the heating up and drying out of these air masses is called adiabatic processes. We have discussed adiabatic processes in a previous podcast, and now we can see the processes at work in the case of the Santa Ana winds. Let's first look at the topography and elevation more closely. Elevations in the high desert Great Basin are around 4,000 feet. Elevations over the mountains east of Los Angeles, such as the San Gabriels, climb to 10,000 feet. by the time the air mass moves into the LA basin, it descends to sea level, ultimately reaching 0 feet of elevation. The temperature of the air changes as it moves over these drastically different elevations due to the pressure exerted by the thickness of the atmosphere above. Air that had a temperature of 75 degrees Fahrenheit over the high desert expands as it climbs over the San Gabriel Mountains because the air mass is much thinner and does not exert as much pressure on the air molecules. That expansion causes the air temperature to cool significantly. As the air descends down into the LA basin, it compresses due to the thicker layer of atmosphere above and heats up as a result of that compression. Compressional heating also happens when air is squeezed through narrow canyons and passes. So let's look at these temperatures one more time. Air that had a temperature of 75 degrees Fahrenheit over the high desert, being pushed by these winds through this varying topography, going up to 10,000 feet or more, cools off to 42 degrees Fahrenheit. As that same air mass descends and gets pushed and compressed down into the LA basin, heats up to 95 degrees Fahrenheit. And these are the actual temperatures that have been recorded through this varying topography during Santa Ana wind events. So thinking again about the impacts of Santa Ana winds on California wildfires, easterly winds prevent cool marine air from the Pacific Ocean from flowing inland, so humidity levels are extremely low, 5 to even 10%. Low humidity, in addition to extremely hot temperatures, dry vegetation, and strong winds, create that deadly perfect storm that make the Santa Ana winds so notorious. For firefighters, these hurricane-force winds make it extremely dangerous and difficult to fight fires either from the ground or water-dropping aircraft. Many writers and songwriters have described the Santa Ana winds in their artistic works because the Santa Ana winds have had and continue to have a devastating impact on the lives of people in California. I leave you with a quote from Raymond Chandler's short story, Red Wind, with music by Jason Mraz. Desert wind blowing that night. It was one of those hot, dry Santa Anas that come down through the mountain passes and curl your hair and make your nerves jump and your skin itch. On nights like that, every booze party ends in a fight. Meek little wives feel the edge of the carving knife and study their husbands' necks. Anything can happen.
Feeling less my ordinary self, I guess I must be getting older. The fog already heavy on my mind evokes a time that's turning colder. At breakfast the effect is picturesque. The window opens up and lets in the Santa Ana winds again. She's a silent love song, never stays long, does not belong to any person, though she's opening the curtains in my